In the last video, we discussed the concept of uniform distribution. We also looked at standard normal distribution and how to find the area or probabilities under the density curve of a standard normal distribution, given the z-score. In this video, we'll revise the process and we'll learn how to find the z-score given the areas or probabilities.
It is very important to understand the difference between z-scores and areas. Remember, z-scores are distances along the horizontal scale, and areas are regions under the density curve. Table A2 lists the z-scores in the left column and the second decimal in the top row, but areas are found in the body of the table. We should also remember that the z-scores on the left of the mean are always negative, and the z-scores on the right of the mean are always positive. And also, the table A2 depicts the areas that are located on the left of the given z-score.
Let's use the same example with the bone density test we looked at in the previous video.
A bone mineral density test can be helpful in identifying the presence or likelihood of osteoporosis. The result of a bone density test is commonly measured as a z-score. The population of z-scores is normally distributed with a mean of 0 and a standard deviation of 1, so these test results meet the requirements of a standard normal distribution. Find the bone density score corresponding to P95, the 95th percentile. First step when finding z-scores from a known area is to draw a bell-shaped curve and identify the region under the curve that corresponds to the given probability. Since we need to find 95th percentile, we will shade 95 of area under the curve to the left of the z-score. Why to the left of the z-score? Well, let's do a little flashback about the percentiles. Percentiles are measures of location, which divides a set of data into 100 groups with about 1% of the values in each group. 95th percentile is the score that separates the lowest 95% from the highest 5%. So we will be looking for the area to the left of the z-score. Here's the 95% out of 100. We need to find the z-score. Let's first use table A2. We'll use the positive z-scores part and we'll search for the area of 0.95 in the body of the table, and then find a corresponding z-score. Let's search for 0.9500. 0.9500 is not here, but I can see that there are two areas that are pretty close, 0.9495 and 0.9505. Both of these areas are 5/10,000ths of the area that we need. So we can assume that our area will be located in between these two. And we can see that there is the asterisk taking us to the special note. Area of 0.9500 corresponds to the z-score 1.645. So 95th percentile is the z-score that is equal 1.645. Now let's use StatCrunch to find the z-scores from the known area. To find the z-scores from a known area using StatCrunch, go to Stat, Calculators, Normal, enter the area, 0.95. Make sure that you highlight which side of the z-score you're looking the area for. In this case, we are looking the area to the left of the z-score, so the sign is less or equal to. If you need to change the sign, the area is on the right of the z-score, click on the sign and choose the greater than sign. Click Compute. The z-score that separates the 95% of the area to the left of that z-score is 1.645. In the second part of the same example that we used before, we need to find the bone density test score that separates the bottom 2.5% and find the score that separates the top 2.5%. Let's first draw a diagram. The bottom 2.5% will be a small part of the area on the left. 0.025 as a decimal, and the top 2.5% will be a small area on the right of the diagram. To find the z-score that separates the bottom 2.5%, we can look in Table A2, or we can use the StatCrunch. Because the area is less than 50% or 0.5, we'll be looking at negative z-scores. When using Table A2 to find z-score located to the left, we search the body of the table for an area of 0.025. 0.025 corresponds to z-score of negative 1.9, and then to find the second decimal, we go up. Second decimal is 6. So the z-score is negative 1.96. Now let's find the z-score using StatCrunch. We use stat, calculators, normal. Because the area is located to the left of the z-score, the direction for the probability is less or equal to. Identify the area, 0.025, compute. The z-score is negative 1.96 rounded to 2 decimals. The bone density test score of negative 1.96 separates the bottom 2.5%. Now let's find the test score that separates the top 2.5%. If you want to use Table A2, keep in mind that table shows the areas located to the left of the z-score. Let's find the area to the left of this z-score that we need to find. Since the whole area is equal to 1, and this little piece on the right of the z-score is 0.025, then the area to the left of the z-score will be 1 minus 0.025, or 0.975. So in Table A2, we'll search for the area 0.975 in the body of the table. The area of 0.975 to the left of the z-score will be located in the positive z-scores part in the middle of the table. 0.975 corresponds to the z-score of, first we go to the left to find the first two numbers of the z-score, 1.9, and then go up to find the second decimal, 6. 1.96 is the z-score that separates the left 0.975 of the area. The test score that separates the top 2.5% is 1.96. As you can notice, these two scores are opposite. That's because the bell-shaped distribution is symmetrical. Now let me show you how to find the z-score for the area that is located to the right of that z-score. Go to Stat, Calculators, Normal. We need to find 2.5% or 0.025 to the right of the z-score. So let's type the area, 0.025, in the right box, and then make sure you change the sign from less than to greater than, because we're looking to the right of the z-score. And here's the z-score, 1.96 rounded to 2 decimals. One more important concept for today, critical value, which for a standard normal distribution, it's a z-score on the borderline separating those z-scores that are significantly low or significantly high from non-significant. The expression z of alpha denotes the z-score with an area of alpha to its right. Alpha is the letter of Greek alphabet. So for example, z of 0.025 will indicate that we need to find the z-score that separates 2.5% or 0.025 on the right of that z-score, z of 0.025. And we found it before, it's equal to 1.96. 1.96 and negative 1.96 are the common critical values. In the next video, we will look at real applications of normal distribution. Stay tuned.